So the Rutherford model of the atom consists of protons and neutrons in the nucleus of the atom and electrons in orbit round about that. Now, it's fairly straightforward to add and remove electrons in an atom. You can do that by rubbing something against your hair, creating some static, and that's just moving electrons around. So usually when we're defining atoms, we tend to talk about the number of protons and the number of neutrons in it, and accept that normally there would be an equal number of electrons to the number of protons. So the numbers that are used to describe this are the atomic number and the mass number, and they tell us about the protons and the neutrons. So the atomic number is the number of protons in an atom, and that's what defines each element to be what it is. Okay, so carbon will always have 6 protons in its nucleus. The number of nucleons, which is the combined number of protons and neutrons together, is known as the mass number. So basically these are the heavy particles within an atom. But it's just a count, so it's not their precise mass, but it's just a rough count. And normally we write these this way around. So you have a symbol for the element, which you can look up in the periodic table. Remember, that's in the data booklet. And then you have the atomic number at the bottom and the mass number at the top. So for example, carbon would be written with a capital C as the element symbol. Atomic number, it's the most common carbon. So atomic number is 6 for carbon, and the mass number for the most common carbon is 12. So it's not actually a mass, the mass number it's saying there. If you want to work out the number of neutrons, then you would subtract the atomic number from the mass number. And the nucleus of all atoms of the same element contain the same number of protons, but you can have different numbers of neutrons, and they are called isotopes of that element. So I mentioned carbon-12 there. You can also get what's called carbon-14. So the atomic number is still 6, but carbon-14 would have 8 neutrons in it. That's another reasonably common isotope of carbon as well. And there's a couple of examples for nitrogen, for instance. So nitrogen-13 and nitrogen-14.